All right, well, hey there, welcome everybody once again to Astronomy Daily Live. So this is ADL for the 4th of March, 2019. So this is one of my favorite days um, of the year because it is also a command. It is March 4th, March 4th. So yeah, hope everybody's doing well out there. Everything's good here. Had a pretty successful day running my photometric transformations through various grinders to come up with some pretty good results. So I'll show you those here momentarily, but I'll let everybody kind of come on in and do all of that. I'm seeing again some pretty good activity over on the chat pre-show, which is always very cool. Uncle Bill is over there. Andy Cowley, Jim from Carolina Sky Astronomy is there. I think Chris from Elliott Astro Imaging is there. So yeah, very cool. Glad to see everybody. Glad to see everybody popping in once again. So yeah, this is a daily live stream where we just talk astronomy and space and science and all kinds of other nerdy things. And tangents are definitely allowed here from time to time. So yeah. Hope everybody's doing well. I'm trying to decide. I've got this sort of bank of clouds moving over now, but what's been happening is that it's been clearing up in the mornings, right? So 1 or 2 in the morning until sunrise has been completely clear, really dry, really nice, and so I'm trying to decide. Well, one, if I want to do that, and then if so, what to actually do. I've got a number of different things to check out. There's another eclipsing variable star that is going to be doing its thing at a pretty reasonable time. I've also got Jupiter up, and it's not doing anything actually necessarily interesting at the moment, but I actually want to do a Jupiter Moon photometry program. The moons, at least the 4 Galilean moons of Jupiter are tidally locked to Jupiter, just like our moon is to Earth. So exactly the same face is always pointed towards Jupiter, which means that as from our perspective, as they rotate around Jupiter, we actually see different sides of the moons. And in theory, you can get a photometric curve. So I'm interested in sort of doing that. But before I get on too far, I want to make sure to say howdy to Bobby in the panel. Hey, what's going on over there?
Nothing much. And I'm on work mode, which shut me out unless you want me to turn it off.
Check Me Out is a great site over on Twitch. She does the singing bowls and a number of other interesting, very calming and very nice sounding.
Which are usually like tank drums or those wind chimes.
Yeah. So she's developing quite an ensemble over there of
yeah. I mean, I think I like. No, I don't have the Discord app on my phone anymore since I had to replace it with another app.
Mm. But yeah. So she's over on Twitch, and I'm thinking that why don't I'm going to very rapidly
As we
post a
are,
link.
we'd like to welcome Ingrid from Brazil.
Hey there, Ingrid. Nice to see you again. So I'm going to copy and paste the check me out Twitch link over on the chat. If you're into chilling out and sort of just doing a little bit of meditating and quieting your mind. Oh, okay. Thanks, Uncle Bill. I was just about to do that, but now I will erase what I just wrote and so yeah, it's a nice chill channel over there if you like to chill out a little bit and just hear some nice sounds, some nice beatings, just yeah.
Now, if you're
It's
also on Check Me Out's Discord, she is asking anyone if you want to be like knighted and stuff, which is usually like Twitch's way of moderating, being a moderator.
Yeah. She's her channel is growing and she needs a little extra help. She's hopefully she's just not going to do that to anybody that asks. She definitely wants to check you out too. So
Hey, it's like I say, you gotta be known before anybody before you get to become part of her club.
Yeah. I
Jill's
am
the same way too.
Yeah, I definitely am not going to volunteer for that because that would require me being responsible, and I'm not interested in being responsible whatsoever. No, I will just go over there and thoroughly enjoy her sounds and yeah, that sounds like work.
Sounds like almost a complicated thing to do, huh?
Well, it's just much more responsibility than what I want to have. so, and that's why I don't really do it here either, right? Because if you're a moderator, you've got a job, right? And well, one, this live stream is small enough that I think I've got 3 mods at the moment, and that is more than enough to to keep track of everything at this point. And 2, yeah, I mean it's a job, so I mean it's not. I mean I don't see it as a privilege. I see it as a job. So who wants a job? I don't want a job. So yeah, but she's doing really well. She's growing and needs some extra help. So if you're interested in those kinds of things, get on over there, get yourself known and trusted, and yeah, you can become part of that crew. So, all right, well, cool. Well, I hope everybody's doing extremely well. As I said, in fact, we can, I can go over to my little satellite viewing site here, and I can sort of show you the situation that I've got. So I will share my screen here and hide that, and I'll show you that. So let's see, this is as of 1:45 UTC, so that's about 25 minutes ago. I've got these thin clouds over me now. I'm about here or so, but see, I've got this big this big bank of clouds here that's actually pretty rapidly moving over the land. Let's see if this will load and not cause my system too much trouble. So moving in pretty quick, right? So not quite sure. Maybe it'll move a little bit to my north. I don't know if you're seeing that or not, but I've got this other mass here. So looks like I'm actually going to clear up here for a little while. So yeah, we'll see how all that goes. So all right, well, since I'm over here, I might as well go over to the to my Discord server and just show you a little bit of progress on my what I'm trying to do is I'm trying to gain confidence in my system to actually be a accurate.
So we're looking at that Messier 46 you captured.
Yeah. Well, this is part of the program, as I was just saying, of raising my confidence in being able to do both accurate and precise photometry, right?
And I'd like to welcome Andy Cowboy and Deep Sky Do. And Andy, I didn't see the SpaceX talk with the ISS. Is it on the SpaceX channel or on the NASA channel? I can check my sources for that as well.
Yeah, it's all over the place. What is Andy asking about?
That module docking with the ISS.
Yeah, that was a success. Definitely was a success. And the astronauts in the ISS actually entered the capsule, and I'm not quite sure, what they're doing in there, but they wanted, to check it all out and make sure that all is well. But yeah,
probably the Russians are going to be jealous.
Well, I hope that there isn't any kind of jealousy there at all. I would think that the Russians would be as excited about that as we are, with them. So yeah, this competition thing is over. Space is big, and we need as many involved as we possibly can. So yeah. No, I think Soyuz that had better continue, right? Because it's awesome. So all right. Well, anyway, so these are two stacked images. One using my red filter, and the other using the green filter. And I have stretched these enormously just to sort of show a little bit of the noise here, and of course showing off the planetary nebula there as well. NGC, what is it, 2438. So yeah, I've just taken I think I got about 170 or 180 total 4-second images stacked here. But now, to me, right, this isn't very telling, right? This doesn't really tell me much. You know, if I was doing photography and stuff, I would say, yeah, that's okay. You know, not really seeing anything terrible there. Yeah, I mean, it's okay. So that's the green, and or that's the red. That's the green. And, you know, we're seeing, you know, some differences in like the morphology of the planetary and stuff. But what I'm interested in, right, is the brightnesses of all of these stars, right? I want to measure the magnitudes of these stars and then compare my measurements to a known standard set of measurements, right? And see how close I can get, right? And if I'm within, um, you know, depending on the magnitude, but if I'm within about 1% or so of what it should be, then I'm a pretty happy camper, right? And so I have done that, and actually these plots to me are actually much more interesting and revealing. So I will show those off in instead, and I will try to explain what is going on here. So what I've done.
Anybody else has been full flu as well? Like this weekend at my church, everybody's sick.
Oh yeah, everybody's sick.
Hey, I got the
Huh.
flu shot, so I'm good.
Oh, okay, cool. Yeah, I haven't, you know, I haven't been ill with a cold or a flu in, wow, it's been well over a year now, I think. So at least.
You still
Any,
probably might need, if they're not out yet with flu shot.
yeah, I haven't gotten any kind of shots in quite a while, and I ain't gonna. No interest in those kinds of things. My
Don't like needles?
No, I just I think this particular body seems to be working okay, and so
Yeah.
it doesn't seem to need any help.
See,
So
it's not just the fact that I love needles. I wouldn't mind anybody sticking to me and giving like a vaccine or something.
mhm.
But the medicines I take, every once in a while, I might have to go to the lab at the hospital, and I have to do some blood work and stuff.
Yeah, absolutely, absolutely. So yeah, you know, no, I'm definitely not gonna be like against any of that, but my attitude is that if everything is working okay, I'm gonna leave it alone. So I'm not
Just whatever
going.
you do, next time you have to do another cancer screening, don't opt for a stool option.
Okay, all right. Anyway, so along the x-axis here, we have the Sloan G magnitude. So Sloan is a standard photometric system, and um, I have found the G magnitudes of quite a few of the stars in that field of view, right?
So
So
Jim is asking, are those are inverted shots?
oh, are you talking about you're talking about you're talking about these? Yeah, I've just flip them around, right? So yeah, you know the stars, the white stars are now black, and of course the black background is well almost white. You know, it's a gray, right? But these are yeah fully calibrated, and then stacked, right? So I've stacked, as I said, I've got about 170, 180 of these images, right? So these are sort of the raw um, um, pictures here, right? And so I've taken, 180 or so of these and just stacked them up to make this. And then, yeah, just an inversion to actually make the stars pop out a little bit more, right? Just to be able to see them, right? But then what I've done is I have identified which stars are which, and I've gone to the Sloan catalog and found their G magnitudes and their R magnitudes, and through a transformation process, measured, actually made measurements of my data here, right? Measured the brightness, say, of this star, right? And compared that to what Sloan says it is. And so on the y-axis is actually the difference between my measured magnitude and Sloan's. So as you can see, even out to magnitude 14.5, I'm getting about 1/10 of a magnitude or so, maybe a little bit more than that. Now there's a lot of scatter here. Yes, 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 absolutely. And so, I sort of want to understand what the scatter is. But for the most part, the accuracy here, even out to 12th or 13th magnitude, is pretty acceptable, right? And if you grab your handy dandy calculator, right, and let's just say in the extreme, right? Now this one's probably an outlier. A couple of these others are probably outliers. You might have to understand exactly why, right? I've got these weird ones out here, but if you sort of take this basic trend here, right, then even at around 14th magnitude, I've got an accuracy of about 1/10 of a magnitude, right? So if you grab your handy dandy calculator and take 0.1 and divide it by 14, right? That's point 0.07, or sorry, 0.7%, right? Which is quite extraordinary, right? So even these faint guys, right? I've got less than 1% photometry, and for the brighter ones, right? As you can see, I'm doing really good, really good. So pretty happy with that. Let's see. This is the G magnitude one. I'll show you the the R magnitude one as well. So there's for R, and again, it's I mean, the accuracy does go down as I get fainter and fainter, which is exactly what I expect, right? But out to about 12th magnitude or so, I'm looking really good, and even really faint, I'm still doing pretty darn good. So relatively happy with that. I think my confidence in this system is growing. So yeah. Now the only other thing that I want to do with this data is I want to do a little bit of work with this planetary nebula here. I want to do some radio profiles. I want to actually try, to measure, some magnitudes here. See how bright, certain portions of this planetary are, and it's kind of interesting, right? There's sort of a, here, I'll open this up. There's sort of a brighter area over here and over here, and there's almost a gap here, right? So this is the red filter, and if you look at it, if you look at the same one with the green, you'll see that there isn't so much of a gap. This is a little bit more extended. Yeah, so there are definitely differences here. Now, one thing that you might be able to see, and I still have to understand how much this is actually affecting my measurements, but you might see really, really faintly here these little wispy tails that are coming off the brighter stars, right? So what that is, and I don't know if you can see that or not, but what that is, that's actually the effect of the shutter opening and closing. So that's a sort of a known effect. I think it's pretty low level, so I don't think it is necessarily going to be affecting my measurements all that much, but it is definitely making a contribution, right? How much? I don't think very much, but yeah, I definitely want to quantify that as well. And you can see it in the red ones as well. If you didn't already see it, it's a little bit harder to see here, but there's some, yeah, there's these weird stripy things, which, yeah, I don't know if you'll be able to see that or not, but overall, I'm relatively pleased with the progress of this. As I said, I think I don't remember exactly how many stars are represented here, but I want to say there's something like 65 or 70 stars, that were found in this field of view. So that's a pretty decent sample, which is why I chose this cluster, right? Because it has a nice rich field of stars over a relatively wide magnitude range, and it also has a bonus object, right? So I'm going to be able to do some measurements with that as well. So yeah, I think that's going along relatively well. I think what I want to do is actually also take some data with my blue filter, because then I'll also be able to compare that to the Sloan B system and see how that goes. So yeah. I think overall, as I said, this is looking pretty good. I don't think, as far as resolution goes, I think this is about pretty much as good as I can expect it to actually be, right? If you look at these fainter guys, which haven't been, stretched to death, and now this is going to look a little bit bad because this is a JPEG image, so things things, you know, are going to look a little funky. But let's pick out like this guy, right? So these images I took were all binned on camera 2x2. So every pixel on here is about 1.8 arc seconds in size. And as you can see, more or less, right? Every star, at least the peak of every star, is falling on basically one pixel, right? And then there's a little bit of a spread, right? And that's why, you know, when you stretch these things out, that's why, you know, the brighter stars look like blobs, right? But if you look at the unstretched stars, they're basically falling on one pixel. And so, you know, I would say, you know, that the seeing that night was average-ish, you know, probably around, you know, one you know, to 1.5 arc seconds or so. And so, you know, the fact that I'm seeing, you know, these stars basically falling on one pixel with a little bit of a spread, that looks pretty good too. So yeah, you know, I haven't done any kind of astrometric measurements yet, but I definitely want to do that, just to see how, you know, the accuracy and precision there is as well. So, but yeah, I'm pretty happy with that. As I said, you know, these images for me don't actually tell me much, right? If I was doing photography, I think I would be pretty happy with that. But I'm not. So it's like, okay, you know, it's data. Let's look at the numbers, and that's what these plots show, are the numbers. And when I look at the numbers, I'm pretty happy with those. Pretty happy with those. So yeah, I think so far so good. So we'll see how that progresses. And as I said, you know, this gives me some confidence that, you know, the measurements that I do make are actually going to be scientifically valid, and that is the whole point, right? All right, well, cool. I think what I wanted to do was I wanted to continue moving around in the constellation of Leo, which is our almost sort of long lost constellation of the month, I guess. So I think what I wanted to do was actually focus on one particular target, and that is one of the Messier objects in there. There are 5 total, and there are lots and lots of galaxies. Lots of them are relatively easily visible with, you know, just a small scope, you know, like an 8-inch scope or a 6-inch scope. With a 6-inch scope, you can definitely see all the Messier objects. With an 8-inch or a 10-inch or a 12-inch, there's a bunch of other ones as well. Mostly, you know, galaxies, right? Leo is a galaxy-rich constellation. I don't know, you know, I don't know if there's necessarily anything else. Like I mean, I'm certain. Let me switch back to my ugly mug for at least a moment here. I don't think that there are any open clusters or globular clusters or nebulae or anything like that. We're sort of looking, you know, sort of outside of the plane of the galaxy, right? Of our galaxy. And when you do that, you know, most of the clusters and most of the nebulae, they sort of congregate in that disk of the galaxy. And so when you look outside of that plane, right, then you're definitely not going to see as many. And I think in the case of the constellation of Leo, I don't think that there's much of anything except galaxies, right?
And
Now,
speaking of mugs, do you think he's like wanted by the FBI or something?
who's that?
You.
Me? Well, as I keep saying, I'll never tell. I'll never tell.
Don't shoot
All
the
right.
messenger.
That's right. That's right. Exactly. Exactly.
Or better yet, don't shoot the piano man.
Yeah. Well, both, you know. Yeah, for sure. So I think what we should do, let's focus in on one of the Messier objects. And I'm suggesting that we take a little closer look at Messier 65. Now, the reason why I choose that is completely arbitrary. I just that's I don't know. Sounds like a nice number. So what I've done is I've set up Simbad over here. The other thing that I want to do actually, and let's actually do this first. Let's go over to the HST archive and see if HST has ever observed this object. I can almost pretty much guarantee that the HST most likely has. So, but you never know. You know, maybe they, you know, maybe it isn't as interesting as I think it is. But somehow I have my extreme doubts there. So, all right. So I'm sharing my
Doubt your doubts
screen.
before you doubt your faith.
What's that?
Doubt your doubts before you doubt your faith.
Yeah, absolutely. And you know, this live stream does emphasize skepticism, which is doubt, right? Right? It's okay to doubt things. So let's go M65, and we'll just check them all out. Oh, by the way, I don't know if you all heard, but I guess the other day, February 28th, the ACS detector on the HST went through some kind of a fault. So I haven't seen any follow-up on that or not. And ACS, shoot, I think that I don't remember what the ACS stands for. So let's find out. The Advanced Camera for Surveys, yeah. So I think it's an imager and a spectrograph, if I remember right. Instrument design, instrument documents, data handbook, instrument science reports, ACS, let's see, overview, here we go. Let's see. So the ACS is a third generation HST instrument and includes 3 channels: the wide field channel, okay, the high resolution channel, and the solar blind channel. Okay, that doesn't tell me much. I thought that it talked about exactly what was going on here. There's the path. Okay. So, all right. Well, I guess it's just an imaging thing, but there's a few options, I guess. So, anyway, so I guess they were having some kind of problems with that. I don't know what the what is going on with that at the moment. It's been a few days, haven't seen or heard anything. Maybe we can just. Oh yeah, that's exactly where we were. So let's see. Let's actually see if the ACS website has any news in education. I wonder if they've talked about it at all yet. Make astronomy exciting, engaging, understandable, and relevant. What do you want to do that for?
I guess it's just to wait till 2021 when the James Webb is gonna do something about it.
Yeah, let's see. Press releases. Let's see if there's anything with press releases. Latest Hubble
That's a
news.
good idea.
Hubble continues to operate normally, executing observations of all 3 science instruments, WFC3, COS, and STIS are all performing nominally. Here at 8:31, the advanced camera for surveys aboard NASA's Hubble Space Telescope. Yeah, so this is the press release I saw. Suspended operations after an error was detected as the instruments was performing a routine boot procedure. The error indicated the software inside the camera had not loaded correctly. A team of instrument system engineers, flight software experts, and flight operations personnel quickly organized to download and analyze instrument diagnostic information. This team is currently working to identify the root cause and then to construct a recovery plan. So that's the latest news, right? There doesn't look like...
and there's always blow up the Hubble.
What's that?
There's always blowing up the Hubble.
Well, yeah, that would make a mess though. So I don't recommend that. Yeah, I think we need to hopefully they'll be able to resolve that.
When you get through with the object of the day, I got something to do, like Lily said, that was on shortwave radiogram, but we'll wait until you're done with your object of the month.
Oh, all right. All right. Well, let's see if HST has ever looked at Messier 65. I'm going to be extremely surprised if there's nothing here. Did I hit the button? I thought I hit the button. I'm going to try it again. Bang. There we go.
There it goes.
All right. Yep. As I suspected. Not as many as I thought there would be. But let's take a look here and see. So, hasn't really been observed recently. But so the last time it was observed by HST was November 14th of 2001. So, wow, quite a little while ago.
Yeah.
Looked at it with WIFPIC 2 at 4556 angstroms and 8012 angstroms. Let's see what these guys were up to here. And I say guys, but I'm just sort of saying that in a generic sense. So we can actually look at the proposal abstracts. The recent surveys of star-forming galaxies in the nearby universe are discovering significant supernovae, which have massive star progenitors. The already extensive HST archive and high-resolution ground-based images of galaxies within approximately 20 million parsecs enables us to resolve and quantify their individual bright stellar content. As massive evolved stars are the most luminous single objects in the galaxy, the progenitors of core collapse supernovae could be directly detectable on pre-explosion images. We have detected one Type 2 progenitor this year and have proposed a short companion WIFPIC 2 proposal to confirm this candidate and identify a second. This SNAP proposal aims to increase the amount of WIFPIC multicolor pre-explosion. Okay, so they're doing some imaging to hopefully put into the archive a record from which they or someone else can draw from at a later date once a supernova occurs, and say, there it is, and we have the progenitor. That is one of the mysteries, right? We don't really have a good grasp of what these stars are doing before they blow, right? That follows the scientific path of curiosity, right? I mean, we're extremely curious as to, okay, we know that stars explode, single stars explode, and we think it's because of a core collapse, but and after the fact, right? When there's a supernova explosion, right? It's like, there it is. But it'd be nice to know what these stars were doing, or at least what they look like, what their characteristics are, right? We can measure their color. Might be able to take a spectrum of them and see, what they're made of, before they explode, right? So I think it looks like that's what these folks are suggesting, that you basically, just take some good data and hope that one of the stars in the field of view actually pops, and we'll be able to do it. So yeah.
Jim was saying, we all hope to get to see Betelgeuse go supernova.
Yeah, well, we're hoping that's going to be a bright one for sure, and we certainly have a lot of information on the progenitor, right? I mean, we've yeah, I mean, we've got a lot of info on that, and are closely monitoring it. I don't know how closely Betelgeuse is being monitored, right? I mean, is it being watched every second, every hour, every day, every month, every year? I don't know. But I know, and photographs, right, taken with a smartphone or that, those are.
I'd like to welcome Chuck Naglum.
Hey there, Chuck. Nice to see you in the chat. Cool. Those photos are moderately useful, right? But what we need is actual scientific measurements, right? Measure the brightness, measure the color, take the spectra, right? All of that. That is what is really going to help us understand, what is going on in these stars prior to exploding, right? And I mean, honestly, we don't really know for sure if Betelgeuse is going to explode, right? There's every indication that at some point it probably will, right? But we can't be 100% sure. I don't even know if we can be 90% sure. I don't know how confident we are in our models, right? But there, I think there's every indication that it probably will. Anyway, so let's take a look at these images and see what's going on there. So that's pretty nice. Let's see, that's a 230-second exposure, right? And these.
Oh my gosh, Chuck! I wonder if Chuck Naglum had a power outage, and Jim is saying, or it could already been, but the light haven't gotten to us yet.
Yeah, That's extremely true. I think Betelgeuse is something like what is it, 800 light years away, something like that, maybe even less. I forget. So yeah, you know, the information that that an explosion uh, took place could be traveling to us right now, right? And it's traveling at the speed of light, which, you know, supposedly is the fastest thing, you know, that kind of information can move. So yeah, we are waiting. We're waiting. Anyway, these that I'm pulling up here are just JPEG images, right? So they are definitely not the greatest in the world, right? But I'm thinking that within this data, they can probably identify quite a few individual stars, right? Now they're definitely not going to be able to identify everything.
So
And
Jim is
again,
saying, I'm not sure I'm not sure what object he was talking about, but this the Earth's about 642 and a half light years. So are you talking about Betelgeuse
yeah,
or the Messier?
yeah,
That'd be yeah. I know what you're talking about.
yeah. No, that is definitely Betelgeuse. Um, Messier 65 is going to be millions of light years away. So yeah, yeah. He's talking about Betelgeuse for sure.
Okay.
Anyway, so pretty nice. And again, you know, these images are inverted, right? So the bright stuff is dark and the dark stuff is bright. And M65 for sure is at least some kind of a spiral galaxy, and we can see all kinds of dark stuff in here and light stuff, lots of
Oh,
structure.
shit, Meow just brought in the gong.
Yay! Bring in the gong. Bring in the gong. Anyway, so that's a nice shot there, right? Pretty nice. So that was taken at 4556 angstroms, which is quite blue, right? Almost into the violet, right? And then so it looks like they took a couple of those. So let's see. This should look about the same, right? Same exposure time, same everything. Cool. And then they took two more 230-second exposures in the red, very red, 8,012 angstroms. So this will look probably moderately different, I would think. Yeah, a little bit, right? So, you know, we're seeing different kinds of material. Different things emit at different wavelengths, emit and absorb at different wavelengths. So yeah, you know, there are differences in these things. These guys here, I would say, are probably foreground stars. So these are stars, and maybe there's one there too in the middle. These brighter guys are definitely foreground stars inside of our galaxy, right? You know, we're looking through our galaxy to this one, but it's kind of hard to tell, right? There's some fainter ones back here. Yeah, this is definitely not, you know, the format to really be able to pick out individual uh, stars. I'm wondering, oftentimes, yeah, they'll have some related papers. I'm sort of wondering, let's see if we can, since this was done so long ago, I'm sort of wondering if we could go back to archive.org and look for papers by Stephen Smart. And in fact, we should go over to, well, yeah, let's just go over to archive. And I'm kind of curious to see if they ever wrote anything up on this. So that's kind of an unusually spelled name, Smartt. So I'll bet you if we just do a search for that, like that, and then let's go under author and see if anything comes up that way. Yeah, so here's S.J. Smart, but we probably have to go back. I wonder, can we can do an advanced search here? Let's do add another term. So let's do Messier in the abstract, and let's see if that kind of nails it down, because otherwise. So there's M85. Oh, that's the only one. Hmm.
Now tell me about S.J. Smart. What was his first name again?
Yeah, it was Stephen Smart. So that's probably right.
Why don't you try the whole name and go from there?
Well, in fact, what I'm going to do, I'm going to see, because see, he's also from the Queen's University of Belfast. So let's dive into this paper and just sort of see if that's the S Smart that we think it is. Queen's University of Belfast. Yes. See, there's a little one here by his name, and you can see there it is, Queen's University. So yes, this is indeed Stephen Smart. But let's see if.
But we're not going anywhere with this.
Well, not yet, but you know, in science, one must be a little stubborn and a little persistent. So let's see. Let's go. So this is very, very recent. So he's a pretty busy author. Back to 18. Let's see if they made these observations in 2001. Then I'm thinking, shoot, how can we find out a little bit more about this? Find query. Add another term. Let's see. What's the best way to do that? I don't know. Let's just do 65. I don't know if that's going to do it or not. That's
nope.
Nope, no results whatsoever. All right. Oh. Let's go all the way back here in time and see if we can find anything.
2003.
Yeah. So back in 03, there he is right there. Mass limits for the progenitor star of supernova 2001 DU, another type 2P supernovae. Galaxy 1365. Oh, we should do a search for NGC 3623. Here we go. Let's see if that helps us at all. Advanced search.
Can't believe usually not. Is it how many Messier objects actually has the NGC catalog object?
All of them.
Hey.
3623, is that what I said? Yeah.
Maybe you just try NTC 3623, that'd be all right.
Well, probably, but that might even be a little bit more generic. Here we go. Well, we found one. Found one. So let's see.
I don't see that.
Yeah, that's right there.
Yeah, but the smart dude is not.
Oh, he might be part of the additional author list. The smart dude, huh? Sorry, that's a one of those names that I just grab onto. There he is. He's there. Number 6. Wow, there's a lot of authors. There's a lot of authors. But number 6, yep, Queen's University Belfast. So he's still there. Let's see this abstract here. So, well, look, it's sort of cut off here. What? That's not very nice.
That is it. I'm sorry, but that date, I don't know what archive was doing at that time.
I don't either. That's not very nice. Anyway, so 1 year of optical and near-infrared photometry and spectroscopy on the Type 2P supernova 2013 K and 2013 AM. Both objects are affected by significant extinction due to their location in dusty regions in their respective host galaxies. ESO 09-10 and NGC 3623. So cool! They actually did it. They found some supernovae in these galaxies that they had previously observed. So that's pretty cool. I wonder. I wonder if they actually mentioned that anywhere. Doesn't look like it. Anyway, okay. Well, we're gonna move on here a little bit. It sort of looks like, you know, for sure HST has looked at it a couple times. Let's see. Back in April of 2001, it was also
good night, Ingrid.
Looked at. Take care, Ingrid. Thanks for coming in. Whoop. Let's see. Shouldn't be much of a difference here, right? A little longer exposure, slightly different wavelengths, right? More towards the green and the red. But let's take a look and see what these look like.
Chuck, you're leaving too?
See you later, Chuck. Thanks for coming in. Come on in anytime. Anytime you want, for as long as you want. We're easy here. So here we go. Yeah, basically the same looking thing, right? Just at slightly different wavelengths. So that's pretty cool. Yeah. Nice noisy data. This is what it looks like, though. Messy, noisy data. Actually, not too noisy, just kind of messy. But that can all be cleaned up. I don't think,
Oh, Chuck Dackle's not reading.
Oh, he's not? He's not, huh? Oh, okay. I got you. Just saying later to Ingrid. Cool. What a great group I've got here, or we've got here, I should say. Nice to everybody, saying hello, saying goodbye. That's awesome. Great group we've collected here. So here's some really, really early ones from 1995. Wow. Also from with pick 2. So yeah, cool. Looks about the same. Hasn't changed much. Looks like there's a really, really bright, maybe like a star forming region down here. I don't remember seeing it in the other images, maybe because it was way out of field. Yeah, yeah. So, you know, it's way down here. So pretty cool. Pretty cool. I'm a little surprised that it wasn't observed a little bit more, but oh, and here's a Nick Moss image, which is infrared, right? 16,000 angstroms, 1.6 microns is another way to put that. Let's take a look at that. Okay, so they're just looking at sort of one section, and yeah, not much to see. Again, you know, these aren't really the scientifically valid pictures here. These are just JPEGs of the science data, so can't expect these to be extremely detailed or anything. But if you want to see what they were up to, we can definitely do that with proposal ID 7331, snapshot survey. Cool. So they're just going around playing tourist, right? They're just snapping photos at a bunch of galaxies. 134 of them they actually did. Wow. Yeah. So this is actually just one of those, right? Pretty cool. Pretty cool. All right, well, let's dive into M65 a little bit here. I'm noticing we're already running a little bit over, but that's all right.
I still want to like tell you as soon as you get through about, but and I'll give you like a little spoiler. I think there were like 3 groups that were about to launch satellites that's going to give us the internet.
Yeah, yeah. Actually, SpaceX wants to, and there's a European group, right, that is just doing that. Why don't you tell us about it?
Okay, I just gotta I just gotta get the text file because it was on shortwave radiogram, and I copied the text and pasted it on a text editor.
Okay,
It's
cool.
not the one I want. I want the file manager. I want Donar, which I'm on XFCE. Here we go.
Yeah, I think this satellite internet stuff, I think that is the bomb, right? I mean, you know, I'm in a very rural area here, and if I could get, you know, high-speed internet here, you know, oh yeah, that'd be great.
Okay, so I just got to scroll.
Tell us more. Right. Tell us more.
So there is a plan from OneWeb to launch 900 internet satellites, pretty much in low Earth. But there was like Airbus, and you did mention SpaceX, but OneWeb is technically in the lead. After starting up 7 years ago, the company is finally to launch about 900 satellites in LEO, which is low Earth orbit.
Mm-hmm.
And that's closer to the Earth than most communication satellites. And one reason why the network might work with better performance, as the company puts it. So it'll tell you about low Earth orbit. It's usually somewhere around 1,000 kilometers or 621 miles. But they have some criticisms when it comes to low Earth and medium low Earth, or even geostationary. Let me see. And the problem is that because there are so many dead satellites in low Earth orbit now, it's still going to cause major concerns. But they also said the internet is not everywhere at all. Okay. Um, so they're trying. So one lab is trying to get some global communications and sudden infrastructureless hurricanes, earthquakes, and refugee. Provide low latency band broadband to expand in-flight connectivity and a vehicular cell network for first responders, and have access to like hospitals, schools, libraries, and homes by via using a terminal to ensure relief to communities in need, tools to drive education, access knowledge and opportunities for local business, and building a net neutral network. But they also got some concerns about regulatory environments. Um, they got some people that doesn't want to be online and stuff like that, and I think they use some type of international term called lenities or letting the team down. Um, they say that in the Western world we stay in our evident arrogant wisdom that they have nothing to fight for, or they're playing freedom haters. Um, but a global internet is supposed to be good, no matter what you ask for, and it's free for any challenges, just such as sharks riding a submarine, trans cables, we even have to dig it up and stuff.
Mm.
So and they always say that satellites don't like clouds at all, and they're trying to use the 3G, the LTE, and the Wi-Fi, but they're like dogged by interference. So they're trying to say, why can't you not just do a cable? Well, some countries don't want you to do it and stuff. And there's also jamming. China wants to jam those types of communications.
Raspberry jam.
And what's kind of weird was the U.S. and Russia's on it too. And an infographic show how debris can damage it. So usually mention it. So China wants to do it as well, and has already had customers in Nigeria, Indonesia, and Cambodia. India will start, and the UK will start as well. Russia has voiced its concern over OneWeb's plans, and it fears about that it could eventually compromise national security. Okay, so let's see. I think Google Google is trying to do something with it with its weather balloons. Facebook was doing a solar powered drone, but it does mention SpaceX, Amazon. Let's see. Okay, still looking at it. You're trying to do a net neutral internet, but there's, like I said, there's lots and lots of competition. So you have OneWeb, Amazon, and SpaceX will launch a series of these, and then China and Russia will put theirs into play. But like they say, LEOs are already overpopulated with satellites. Many of them are dead or impoverished. But they don't have. There are no international laws. Does not suggest that you gotta take them out. You gotta put them down. Like put them back down to Earth.
Yeah. Yeah.
And OneWeb is concerned about it.
Yeah.
So,
well,
what they're trying to do is they're trying to do some invasive technologies. And should one of the satellites die, it has the ability to go back to the Earth with pure intent. So that's usually about it.
Very cool. Yeah. Well, we're entering sort of a new era, right? When we have to start thinking about these kinds of things. I mean, being a ground-based astronomer, right? I am moderately concerned about all these thousands and thousands of satellites um, going around the Earth. Not necessarily just for the problem of space debris, but also um, you know if I uh, uh, if I have an instrument, right, that I've got turned up to 11, right? I mean, I've got it on really high gain. Um, say that I'm looking at a really faint object, right? And so I've got the gain turned up, right, cranked, right, to 11, right? I don't want some bright satellite to fly through the field of view, even a short amount of time, um, has the potential of destroying um, my stuff, right? I don't want that. And uh, if it isn't reflected light from the satellite, maybe the satellite um, is not reflecting anything and is actually blocking light, right? So if I'm, making, a very careful measurement of the brightness of a star, right? Well, I don't want it to suddenly dim because the satellite flies through, right? But yeah, there are going to be thousands and thousands and thousands of them up there, because having you know basically worldwide Wi-Fi whenever you want it. Um, I mean, I think that's great, right? Sign me up, right? The closest that we have to that right now is sort of like the cell phone network, right? Which I mean is just fancy Wi-Fi, right? But those are in very limited areas, and you got to have towers, and you got to all this kind of stuff. If you can have a network of satellites up there, a lot like GPS, where they aren't always the same, right? They're moving around all the time. But if you have access to one or two or three of these over your location all the time, then you'll always have Wi-Fi. And I mean, like I said, sign me up, right? As long as it's affordable, yeah, I'm gonna, get rid of these wires and stuff. That's ridiculous to have all these wires and stuff. So yeah, um, it's an interesting thing because it's going to open up the entire world to be able to um, um, these you know um, um, to be able to talk to one another, right? But at the same time, we're going to have an additional thousands and thousands and thousands of these satellites up there, um, which, like Bobby said, right, is going to add a lot of space junk up there. When these satellites fail, or they're no longer used, you have to come up with some way of deorbiting them or removing them, right? And um, I think we're coming up with ways of doing that, right? Space is really big, and there's still a lot of room out there. But yeah, I mean, if we double or triple or quadruple, the number of active satellites up there, that becomes a problem. And in fact, that is one of the many answers to the Fermi paradox, right? Is that the um, um, Fermi paradox says basically that, okay, if there are advanced civilizations out there, why don't we see them, right? Where are they, right? Well, maybe you know civilizations advance their technology to a point that they are launching thousands and thousands of satellites, and it's not until too late that they realize that they have no way of getting out, right? They can't, get themselves out because they've sort of encircled themselves with all of this crap, and they have no way of safely getting out. So that's why we don't see any of them, because they can't leave. So yeah, who knows? Who knows? But there are ways of mitigating that. And I think you mentioned, Bobby, that there aren't any international laws now, to make anybody do that. But I think it's in everybody's best interest to do that.
Yeah, so what I'm trying to do is I'm trying to upload that text file about that article, but for some whatever reason it's not going to let me and stuff. But what I can do, I can go ahead and like paste the link on the Discord.
Sure.
Which I think will be better off.
Yep, that'll be great. That'll be great. I would definitely like to see that myself, and that way others can also see it. Okay, well, cool. That I absolutely love those kinds of tangents, but that tangent took us a little bit longer than what I want to go on this live stream. So I think for now I'm going to get out of here. We'll grab Messier 65 tomorrow and take a closer look at it with Sinbad, and we'll look at some papers and do sort of the usual thing. One of the great things, of course, about all the Messier objects is that we can see them with a relatively small telescope.
Chuck on space one day will have something like the Great Pacific Garbage Patch, except with satellites.
Yeah. Well, hopefully, we'll do a better job than what we're doing down here. But humans are involved, so I don't know.
Well, I know that. Can we just take a magnet, a good high power magnet, and just thrust the satellites back to Earth?
Yeah, it's Bobby, it's all about delta V. That's all it is. You just have to change their speeds. That's it. It's all you got to do. And the ones in low Earth orbit, they'll come down, right? They'll come down. The ones that you really have to worry about are the ones in those transfer orbits and geosynchronous orbits. But even that, eventually they'll all come down, because we know that the Earth has this thing that's called a geocorona, which is essentially the atmosphere of the Earth, and that actually extends beyond the orbit of the Moon, right? It's really, really, really big. So even out past the orbit of the Moon, there's drag, right? Which is going to slow things down, right? And if you can slow things down, that's why I'm saying it's all about delta V, right? You change speeds, you slow things down, and those things are going to dive right into the Earth. So don't even need anything as fancy as a magnet. You just have to change their velocities. And there's a number of ways to do that, right? So who knows? Who knows? We humans, do have the ability of messing things up pretty well, but we're also, we have some interesting solutions too. It's just a matter of, for a lot of these things, it's just a matter of wanting to. It takes will to do it. It's not that we can't or don't know how. It's that we don't want to. So we just have to change our minds about that. So all right, everybody. Well, I'm going to get out of here for now. So take care. Yeah, there's in this next week, there's a possibility that in fact, pretty likely that there are going to be 2 live streams that are going to be canceled. One is going to be actually in just a couple of days, which I completely forgot about until today. So let's see, 4th, 5th, 6th. I think the live stream for the 6th is very likely to be canceled, and then the live stream for the 9th might also, there's a good chance that one is going to be canceled as well. The one for the 6th, I'm going to a gathering of space people over in Tucson, and on the live stream for the 9th, I'm probably going to be doing a sweat lodge again. So my friend who has a sweat lodge has invited me up, and so I'm probably going to do that because it's been a while, and I've got to ooze a little bit of this goo out of this body of mine. So those are really, really nice to do that. So, all right, everybody. Well, take care, and I will see you again in about 22.5 hours. At least I'll be here, at least. So feel free to come in if you wish. Let me make sure there's nothing else on the stream. Uncle Bill's not going to be here tomorrow. All right. Thanks for the warning about that. Otherwise, yep, I think everything's good. I'm going to get out of here for now. Peace, cheers, and all that. Thumbs up if you so desire. Spread the word about this. Spread the word. Trying to grow this a little bit because the more this channel grows, the more passion I can spread. And that's my entire goal, is just to spread the passion for astronomy and space and science and all that kind of stuff. All right, everybody. Take care. Peace, cheers, and all that. I will see you later. Live long and prosper.
Live long and prosper. Later.